Some things I want you to look at here in particular, there's something called the application server central services. These are specific daemons that run on the system, and they provide the NQ service. And if the NQ goes down, database stops doing everything, right? Until the NQ comes back up. And we preserve that, and we'll show you how to do that so that you can have a highly available system. So here's one way to do it. If these systems are scaled up, these two systems are scaled up, what you do is you would set up something called HANA system replication between the two. And this is something that's included in the SAP software. And what it does is it creates, at the persistence level on each side, a copy of the database. And these systems, this is the primary, getting transactions from the application server and applying those transactions to the persistence level. And those transactions are going through the network and transacting against this database, which can be active read only, right? So you can look at that system, you can see what kind of data is in it. It should be up to date asynchronous or synchronously, which is really real time. This is not open for writing. It would be something else, right? So I have a lot of people say, well, I'll use that as my data store. No, you can't. Because the first thing you're going to want to do is, let me create a view. You said the magic word. You want to create a view. Database is not open for creation. Request denied. So let's do that. And then at the top layer, we have, bottom layer here, we have something called Service Guard for Linux HANA Cluster. And so this is a manual, and once this is installed, it's happening automatically. But until we put something that does it autonomously, we have to move the workload from one server to the next. And we want to do it knowing that this server, or that HANA system, is open, that it's working, that it's going to be able to bear the load, right? It's one thing to say it's going to move, but if it moves to a dead zone, well, then you haven't done yourself any service, right? And we'll talk about that. And then at the application layer, we could provide resilience through extra application service for standard application services. So you have people that are maybe coming to an F5 system and going to different application servers, but there's special services through the central services that have to be preserved through a higher level of service. And there we can use not just an ESX cluster, which gives you an ESX HA cluster, but you can use the VMware HA to move the central services workload autonomously from one to the other in the case of a failure. The reason why it's transparent to the users is for the moments it takes for the workload to move, users will get like a wait state, and then when it starts up again, if it times out, op dump, they have to redo the transaction again. Same thing for here, right? Transfer times, most of the time, between 30 seconds to 1.5 minutes for most systems that I've seen in synchronous mode. And in here, this can happen anywhere from 5 seconds to 20 seconds, right? Very quickly, right? So, moving forward, I like to go through this one because there's two kinds of systems. There's systems where you have a single Linux image where everything is scale up. So you can go up to, with HP hardware, with Superdome Flex, up to 24 terabytes in one Linux environment. Or you can go scale out. When it goes above 24, let's say for a business warehouse, OLAP workload, you have to scale them out by having multiple hosts, and these being, let's say, 6 terabytes apiece, and then you have multiple hosts all cooperating to provide what I call a shared global space, right? In each of these cases, they use system replication for single node for scale up, but for scale out, for high availability, they have something called a host auto failover. It's a capability of SAP software to say I'm going to have one extra node, one 6 terabyte node extra, and if one of the nodes fails, boop, it automatically moves over. In the disaster recovery scenario, you're going to use HANA system replication asynchronously. Why do you move asynchronously? Well, first off, you want it to be far enough away so that if Godzilla is eating your electrical wires outside, right? Hey, we have got to get the heck out of here, right? We got to go move somewhere else. And it's going to be far away so that we know that Mothra is not going to be there, right? Because that's a problem too. So this is usually in a different geography or in a different geographical location. at best design. Okay, I'm not going to go through this eye test here, but just be noticed that these local failover processes have options, and there's pros and cons for them. We do have this information available to you. It will be on the website. All the presentations will. Look through those. I want to just point out one thing. If DR is required in a 3-tier replication, so primary, HA, DR, one is automated, the other is not. So you apply Service Guard to one of them and not to the other. You never move your data center autonomously. You know, you walk into your data center, it's dark. Oh, I guess we moved our workload from Las Vegas to Vancouver, right? And you didn't even know. That's a bad thing. That's a business decision. Okay? Okay. I went through this yesterday, but I just wanted to point out here that this gives you a good view of what there's underlying technologies that not only can be VMware HA, but you can have them using VMware Site Recovery Manager and storage replication if you would like. Right? You have another site with the storage replicated. You have Site Recovery Manager says that's the VM I want to connect to. It connects to the system through the storage connector. Boom, that system's back up and running. You don't have to do it using VMware high availability clusters. Now, what does that mean? You got to have more storage, and they have to be using pure persistence, right? So the two of them have to be in persistence with each other. Here, we talked about this. I won't go over that again. So I'm going to go here because this is really the meat of what we're talking about here. Customers and users who are coming through the system, they are clients, and they're talking to the application servers. The application servers in HANA are different than the old application servers. There's a push down of code that goes from, I'll call it from this anything above the database, where they pushed it down into the database, where you just have, I'll call it certain layers of the application layer that are left. And what that means is, this is holding less state. And there's very few calculations going on here. All that's being done down in here, right? And these constructs inside here show you the primary and secondary systems basically as one system. So the operating systems on both of them are the same. Doesn't really matter though, but you really should. I can't imagine doing it in different databases. But DNS resolution, host names, and virtual IP addresses. I put so many of these systems together, I can do it in my sleep, all right? And you don't have to automate it, but here's the downside of not automating it with Service Guard. Eventually, all of us make mistakes. I know not all of you, some of you don't. And when you do these things through manual moving, what you find is you do step 6, 7, 8, skip 9, and you went right to 10, did 11, and all of a sudden now your database doesn't come up, right? Because you skipped steps and you didn't do all the steps. So anything that's done by people can be undone by people. So automating that process and then doing it automatically or autonomously, moving the workloads, moving what I call the primary package from the first host to run on the second host. When it's automated, it takes the people out of the equation, because you don't want to have to be dealing with a high availability or a DR system event, right? All right, so that DNS or virtual IP address, in my mind, most customers get in trouble because they try to move DNS outside, here, so it goes out, comes back. What if the network is the problem? Well, no DNS resolution, split brain, right? We protect you against the split brain by something called SafeSync, right? So let's say the system's operating happily, and all of a sudden it does, right? We have a Quorum Server. He's not in there somewhere, but he's around. So, it's the next slide. There you go. There he is. We have this Quorum Server, and I'll call it the judge. If these two systems are on the same local network, and one of them goes down, there's a race to the quorum, right? And they both say, "Oh, I don't see the other one through a heartbeat now." Which one is it? In other systems, that thing is called the locklun, and you cannot, if that locklun is not reachable, then you have a split brain. You have two databases with the same virtual IP address, right? The Safe Sync product, or the Safe Sync feature within Service Guard, prevents that from happening because whoever achieves the quorum, and they're on both physical networks, that person or that system will be the survivor, and it'll fence the other one off, right? So that saves you from trying to land on a bad system, and because what's important is the data, not the host. Preserving the data is even more important than making it available to people instantaneously. If the data comes up in a corrupted fashion, what good is it? Or if it comes up where, you know, the index server's having problems and you're looking at your trace files and they're doing all kinds of bad things, you really need to fix that before you turn everybody on and say, yeah, go ahead, start transacting. Because then you're going to get other calls. Right, so let's go forward here. That's a safe think, right? Avoid failing over to outdated data, right? Time-stamped and all. So support for MVC, multi-SID, and virtual HANA. I've done it on virtual HANA because my servers are all virtual because I don't have enough funding to do anything on bare metal deployments, so I have to do everything virtual, right? But it works fine. And so this is one of the last of two slides I want to show you. It kind of shows this synchronous replication with the Service Guard being optional and async being remote. And ever since HANA SPS 11, you can do a different, what I'll call deployment scheme, sync mem. I don't actually recommend that for very often because really it means that the two memories are in sync. And I've found that it can be problematic. I like sync, right? Because sync does that and it sends a transaction and says, hey, tell me you got it. Sync mem, no, you don't get a reply, right? Async, that's log, those are logs, right? Apply the log on the other side, tell me you got it, thank you, right, you're good, right? And then, this one here is if you're doing scale out, I'll let you guys read that for homework, right? So here's another one, and this is important. The systems now, since HANA SPS 04, one, they're more stable, right? And two, these systems can have multiple asynchronous connections, right? And those also, I thought these can, these can be synchronous. This can be synchronous, that can be async, that can be async. There you go. And what that means is, think about this. If you have a system where there's these four that are connected, that is your HA, that's your DR, that's what you protect. You don't let anything mess with that. If you want to create a BW or a snapshot or something that you can play around with, that's this one. You say, okay, as of, Zulu time 1200, we're going to stop that synchronous recreation, we're going to batch up the log files, and then we're going to say, all right, now I'm going to take that, I'm going to rename it, make it my QA system, however you want to do that inside the data hub, the cockpit, right? And just recreate it. Then this becomes a time-dependent system, if you want to do that, right? And that's a real key feature. You have done nothing to your core requirements here, nothing at all. And you never touch these systems, unless you have to, right? So, let me go on one more here. And only one of them is read-enabled, right? So, this is the one that's read-enabled, right there. These are not read-enabled, that's not read-enabled, right? So, okay, what else is new? Multi-target. What's nice about this is that you can have what I'll call low or no downtime upgrades. What it means is, and actually the next slide's better. Nope, that's not it. Graceful, I guess I didn't put it in there. Okay, well, we'll do it this way. There's the primary system that's connected to a local SAP HANA replica, right? And then there's also an asynchronous one here, right? And then there's actually one more that's either synchronous, probably synchronously connected to that. And what you do is you start from the back end, you upgrade that, you break replication, you upgrade that, you then bring this one and use replication to force the database into the second one. Remember now, the database is in memory, all of it. So the minute I force replication, you have upgraded that system. Right now, I'm not talking about whether the executables and all that has to be in the right place, okay? But the data is in the right position at the upgraded level, right? So then you still have primary and HA working, right? At that point, you fail over, you replicate here, you fail back, you replicate there. And you have done what I call low to no upgrade downtime, right? I know it sounds mythical, but it works. It really does. So let's, I'm not gonna do this. This is planned safe sync we talked about. Okay, I wanna get to this one. Everybody's asking the questions. How does persistent memory work with HANA system replication? It does, it's transparent. You don't have to do anything. Put the persistent memory in there, and it works. So what that means is your HA and your DR systems, no changes. That's managed by the SAP system. The SAP system is app aware, right? And therefore there's no need to make changes. That doesn't mean you can't, when you implement it, you have to talk to the system and say, by the way, I've given you PMEM, let's use it appropriately. That's a different story. Once you've done that, then the HA and the DR stuff follows. Is it supported with scale out? Absolutely. And you don't have to do anything with that either, which is an even better answer. Right? And so what needs to be configured? Because it's transparent, you don't have to configure anything. The data in the persistent portion of the memory is just a little bit harder to get rid of, right? It's got a little bit higher latency because, you know, I mean, we want it to be persistent, right? So that information is just not going to go away, and nothing needs to be done there. Is Service Guard certified? Now these are two. Is Service Guard certified for use with HP Primera Storage, our new Tier 1 product, fully certified for HANA? Yes. Right? Is it blazingly fast? Yes. And is Service Guard supported for vHANA systems using VMware? Absolutely. And with VMware version 6.7U3, we can now create VMs as large as 6 terabytes, which is awesome. Right? All right. How to engage? So you guys have my information here. If you need to get a hold of us, you can send me an email. I'll send you to the right person. It's easy. It's first.lastname@hpe.com. So paul.chisari, hpe.com. And I'll send you in, I'll get you into the queue, and we'll get you taken care of.